So we are in section 5.4, systems of equations with either infinite solutions or no solutions. So if you remember, the last section that we were learning was systems of equations, which means you have two lines on the same graph. Usually what happens with these problems is that the two lines intersect at one point, and that's when it would have one solution, and that solution would be whatever intersection point that was. This one maybe could be like -1, 1. There are two other things that can happen, though, when you have two lines. Most of the time, the two lines cross at one point, but then there are times where the two lines are actually parallel and they never cross at all, and that would be a no solution problem because the lines never cross and you're trying to find the crossing point when you're solving a system. Or the two lines can actually be the same exact line, and when the same exact line crosses another same exact line, they cross at every single point. So we call that infinite solutions. So when we're trying to determine if two lines are going to be no solution or infinite solutions, weird things happen with the equations. There's a couple ways you can tell if they're going to be parallel, which means they're no solution, or the same, which means infinite solution. So the first example here, we have y equals 2x plus 1 and y equals 2x minus 5. If I give you a system of equations and I say, what's the solution, your first thing should be, okay, I should solve this either with probably graphing or substitution or elimination. Sometimes, though, you might be able to tell the solution without even having to show any math, but I'm going to show you how you would solve it. I guess we'll do substitution for this one. And I chose substitution because I have y equals 2x plus 1, so I can easily take 2x plus 1 and replace it in for that y in the second equation. When I do that, I'm left with 2x plus 1 on the left-hand side, because I'm replacing that in for this y, is equal to 2x minus 5. Once you complete the substitution step, you should have all of the same exact variables, so we have x's on both sides. So when I go to solve this, I'm going to subtract both sides by 2x to move them all to one side, but when I do that, something interesting happens on both sides. 2x minus 2x cancels out. I'm left with 1 on the left-hand side. 2x minus 2x also cancels out. I'm left with -5 on the right-hand side. And what I'm left with is actually something that's not true. 1 does not equal -5. Because this is not true, that means that this is going to be a weird situation. That means that there's actually no solution to this problem. And there is no solution because these two lines are actually parallel. We can tell that they're parallel from the very beginning. If you look closely, parallel lines have the same what? Slope. So because these two lines have a slope of 2, that means that they will have the same steepness. They're never going to cross. So if I give you a problem and I say, what's the solution? Sometimes you might not even have to solve any math. Like I can look at that and say, there's going to be no solution because they're parallel. And if you can do that without solving it, then that's great. Now, obviously, for the problems that have a solution, you have to actually solve it. But sometimes with the infinite solution and no solution problems, it's pretty clear what happens. Now, in number 2, the equations are not both in slope-intercept form, so I can't really see what's going to happen. So for this one, I would have to solve it using either elimination or substitution. Because the first equation solved for y, I think it's easier to take this, replace it in for y here by using substitution. The substitution step would be 2x plus 2y, but instead of 2 times y, it's going to be 2 times -x plus 1 is equal to 4. Once I have that set up, now it's time for me to solve for x using algebra. So the first thing you would do is distribute 2 times -x and 2 times 1. This turns into 2x plus 2 times -x is actually going to be a -2x. And 2 times 1 is 2 equals 4. When I go to simplify and combine like terms and solve for x, I notice that 2x plus -2x or 2x minus 2x, these are actually going to cancel. And I'm left with 2 is equal to 4, which is also not true. Whenever this happens and the variables cancel out and you're left with a false statement, that means that these two equations don't ever cross because they're parallel, which means there's no solution to the system because the lines don't touch. And like I said, if the equations are in slope-intercept form, like number 1, you could actually just tell from the original problem that they are parallel. And number 2, you could not tell because they're not in the same format, so you would have to solve it with one of the other 2 methods, and I chose substitution. But number 3, I wouldn't choose substitution for number 3. What do you think is the easiest method to use for number 3? Yep, it's called elimination when you try and cancel them out. So the reason why this would be helpful is because they're both in the same format. It's called standard form. And if I take these 2 equations and add them, I'm going to see cancellations happen. 5x plus negative 5x cancels out. 3y plus negative 3y cancels out. On the left-hand side, everything cancels out, so I'm left with 0. And on the right-hand side, 6 plus 3 is 9. 0 does not equal 9, so because of that, that means that there is no solution to this system. So these problems are actually easy because you don't really have to solve anything. Things cancel out, and then you're either going to be left with a false statement, which means no solution, or the opposite on the next page. We'll see that you will be left with a true statement, which means infinite solutions. So when 2 equations represent the same line, all the points on the line are solutions because they're the same exact line. So we say that the system has infinite solutions. So for number 1, if I wanted to figure out the solution to this system of equations, I would first choose to either use elimination or substitution. Looking the way that this is set up, elimination looks like the better way to go because they're already in the same format and I can already see things cancel if I add the 2 equations together. 3x plus negative 3x cancels out. Negative y plus positive 1y also cancels out. I'm left with 0 on the left-hand side. 6 plus negative 6 equals 0. Now, since 0 equals 0 is true, that means that these 2 lines are actually the same exact line. That means that the answer is infinite solutions. Infinite solutions means that these 2 lines are the same exact line, and I can quickly show you that the original problems are the same equation. So if I take 3x minus y equals 6, so 3x minus y equals 6, and if I put this into slope-intercept form, I could subtract both sides by 3x. You don't have to write this, you can just pay attention. Negative y equals negative 3x plus 6, and then if I wanted to get rid of this negative y, I would divide everything by negative 1, and I would get my answer as y equals 3x minus 6. If I take this second equation here, and I rewrite it and put it into slope-intercept form, this would be negative 3x plus y equals negative 6. This one's a little bit easier to solve. I would just add 3x to both sides, and I'm left with y equals 3x minus 6. This equation is the same exact equation as this one. So if I was to graph both of these lines on the same exact coordinate plane, it's kind of silly because you're just drawing one line over top of the same line, which is why every single point is a solution, which is why we call it infinite solutions. Okay? Number 2, we will have to solve it. If you didn't already know, you're probably already guessing that it's going to be the same type of situation, and it will. But if you didn't know that, you would have to know how to solve number 2. You have an option. I think they're equal in difficulty. You can either use substitution, which would require you to solve for one of the x's or y's, which the first x or the first y would be easier. Or you can use elimination, and if you use elimination, you would have to take the first equation and multiply by what? Yep, either -2 or +2, and then you can either add or subtract to cancel out. I kind of like elimination better. I feel like the process is a little bit easier. So I'm going to take the first equation, and I'm going to multiply by -2 like Alex said. And when I do that, it will turn into -2x minus 2y equals -6. And then once I do that, I can take those two equations, this bottom one here and this one here, and I can add them together, and everything will cancel out. 2x minus 2x goes away. 2y minus 2y goes away. I have nothing on the left-hand side. 6 plus -6 is 0. This is going to be another one where it's infinite solutions. Okay, and then we have one more on this page, number 3. Why don't you guys try this on your own? I know you're probably knowing what the answer will already be, but go ahead and try this one, see if you can figure it out. First, figure out if you should use elimination or substitution, and then solve. All right, what method would be the easier method to use to solve number 3? Marlon? Yes, I agree. So substitution means you take whatever y equals or x equals and you replace it in for y or x. So we're going to replace 7x plus 13 in for y right here. So this is going to say -21x plus 3 times 7x plus 13 is equal to 39. And then what we're going to do is multiply everything in here by 3. This turns into -21x plus 21x plus 39 equals 39. Now, you might already be able to see from here what's going to happen. -21x plus 21x cancels out. And this one doesn't say 0 equals 0. It says 39 equals 39, which is still true. And because that's a true statement, that means that this answer is infinite solution. So out of all of the problems, these are actually the easiest because you don't actually have to go through and find x and y. The process ends right after the substitution step or the elimination step because everything cancels out and it's either true or it's false.